Assalamualaikum warahmatullahi wabarakatuh. In this video, I will proceed with the 2.4 transformation of function. So during our last class, we have discussed the example on the transformation technique where you are given the function, then you have to determine the transformation technique involved on that function. So now you are given the transformation technique. Let's look at to the exercise 2. So you are given the transformation technique. You need to determine the function as well as to sketch the graph of each transformation technique. So what we have to do first here is you are given the basic function, which is the modulus function, modulus of x, and the first one shift to the left by 1 unit. So from the modulus of x, what should be the new function here? So let's say I put as y. So y is equivalent to shift to the left, meaning that it should be x plus 1 by 1 unit. And then the next one, reflect about y-axis. So the next one, your function will become, since it is y-axis, therefore the negative sign should inside the function. So negative of x plus 1. And then the next one, stretch horizontally. If it is horizontally stretched, the factor must be inside the function. So it is in this category. And then the next one, since it is stretched, the values of c must be between 0 until 1. Therefore, our c here will become negative by a factor of 5. So it should be negative 1 over 5, not 5. So negative 1 over 5x plus 1. So you cannot put, if you put like this, y is equivalent to negative of x plus 1, the whole thing over 5. So this one is wrong, because when you split between this function, it will become negative 1 over 5x plus with 1 over 5. And it shows that our shift horizontal shifting is shift to the left by 1 over 5 unit. So that's why it is wrong. So the 5 is only belongs to the x. So it is only the factor of x. And then the next one, shift downward by 3 unit. The function should be y is equivalent to modulus of negative 1 over 5x plus 1. So downward 3 unit, therefore it should be minus 3. So what we have to do next is we have to sketch the graph for each transformation technique by using the basic graph. So starting with the basic function. Okay, so let's sketch our graph. So the first one, the basic function, y is equivalent to modulus of x. So how the graph of modulus of x looks like? So we have this axis, x and y. And then on this axis, you have to sketch the graph together with the two starting point. And this one is better for you to put the arrow. So we know that it should be from negative infinity until infinity, the domain. And then for the range, we know that the y values will start from the values of 0. So in this one, we choose the coordinate of 0, 0. And another one, let's say we choose negative 1 and 1. You can also choose another point which is 1, 1. So in this case, I just choose 2 points. Why I choose one of the point here? Because at the end we need to determine the range. So if we decide to have one of the point is 0, 0, so it will be more easier for you to determine the range at the end. So this one is 0, 0. So that is the basic graph. And then the next one, our function for the first part just now. So y is equivalent to modulus of x plus 1. So how to sketch the graph? So your graph is shift to the left by 1 unit. No need to write down the transformation technique anymore because the transformation technique is part of your question. So we just put the function. So will become the coordinate of 0, 0 will become negative 1, 0. So this one is negative 1, 0. And negative 1, 1 will become negative 2, 1. So that is for the transformation part A. And then for the part B, our function y is equivalent to, so it is reflect on the y-axis, negative x plus 1. Therefore, your graph should be reflect to the other side. So it should be left or right. So for this one, this is y-axis, x-axis, and then our function. So the coordinate here for the negative 2, 1 will move to the other side, will become positive 2, 1, and the coordinate of negative 1, 0 will move to the other side and then will become positive 1, 0. So let's sketch our new graph here. So we have the first coordinate is positive 1, 0. Then the next one, positive 2, 1. So the next transformation for the part C, so it is stretched horizontally by a factor of 5. Therefore, so I will draw here, we have C, our function y is equivalent to modulus of negative 1 over 5x plus 1. Then when we sketch the graph, so what is the which coordinate will change? So horizontally stretched or compressed, the changes is on your x. So 2 and 1. So the coordinate, let's say we sketch here, coordinate of 2, 1 will become 2 times 5. So you will get the new coordinate is 10, 1. And then the coordinate of 1, 0. So the coordinate of 1, 0 will become 1 times 5. So you will get 5, 0. So that will be your new coordinate. So we will sketch here. So it's supposed to be you have to show the stretch, so it should be something like this. So instead of 1, 0, now your x coordinate will become double. So we have multiply by 5. So we have here 5, 0, and this one will become 10, 1. And the last function, when you shift downward, so for the D transformation technique, the function is y is equivalent to negative 1 over 5x plus 1 and then minus 3. Therefore, this is how your graph looks like. So the coordinate of 5, 0 will become 5, negative 3. So will be something like this. So the coordinate here will be 5 remain, and then moving downward, which is the vertical values will change. So negative 3 and 0, 0, 1 will become, so 1 minus 3, so you will get negative 2. So the values here will be 10 and negative 2. So this is the new coordinate. And then what you have to do here is you have to determine the domain and range. So what is the domain for this function? Domain for the function f. So let's look, write down the final function here first. So our final function, this one I put in terms of y. So this one I put in terms of y. So we need to put in terms of f. Therefore, the last function after the transformation technique, negative 1 over 5x plus 1 minus 3. And how about the domain of this function? So since there is no restriction values of x, so our domain is negative infinity until infinity. And how about the range? So the range we have to determine by looking at the graph from bottom to the top. So the bottom or the first values of y in this graph is negative 3. And negative 3 must be closed. Therefore, our range close negative 3 until infinity. So this is our final answer for the domain and also range. So I will continue the next video. Thank you.